Good afternoon. Thanks for joining for the session. If you're in the right place, you're here for containerization and beyond, application modernization at scale. I'm Alex Leif from VMware Pivotal Labs, based out of London, currently calling you from my home office, like I'm sure many of you are dialed in from. So yeah, we're going to get straight in here. We've got 45 minutes together. I'm on Slido, so if you've got questions, do make sure to send them in, and we can take those throughout the presentation. So high level, what are we talking about here? Containerization. More than 2/3 of organizations, 69% roughly, have containerized more than 10% of applications, but only 13% have containerized more than half. And so what's this really telling us? It's saying that adoption is probably not as rampant as we expect. If you look at what's in the media, what most of the tech conferences are talking about, you would expect there's 100% of applications containerized out in the wild, and everyone's using Kubernetes. And what we really see is that's not true. And there's many reasons for that, which we're going to cover in this talk. And really thinking about how we can start to accelerate migration to more modern platforms, more modern application architectures, more modern infrastructure. But keep this stat in the back of your mind as we go through the rest of the talk. So I'm going to tell you a story of a monolithic applications journey through a modernization. Many organizations are doing these. This is a real typical journey that we've seen of an application that's kind of written in the last 10, 15, 20 years. And so often, back in 2000, Bob, the IT manager, says we now have the fastest services in the business, right? They invested in Iraq, a great data center, and probably moved a lot of their applications onto these hardware servers. And what do we see? We saw this as managed by central IT, which was slow. We saw it's hard to scale up and never really scaled down, right? You just added more racks or more CPU or more RAM, and it never really came down, which cost a lot of money and really just kind of sucked to manage. We saw chuck it over the wall deployments. This still happens today, but a lot of centrally managed IT teams, you have an operations team, you take your software, your monolithic application, you give it to them, maybe a few weeks later it's deployed. And then really these snowflake environments were treated as pets. It was an honor to see how long the server had been up and running without having any downtime. And each of them were managed in a really custom way. So then Bob in 2008, says we're all in on virtualization. We want all of our applications to go into virtual machines, which is no problem here. But it was faster to spin up and take down VMs on demand, right? Which gave teams more flexibility. You could get a VM within minutes or hours rather than weeks and months for your hardware. You had portable across environments. You're able to take this VM and run it on your desktop, run it on your company's infrastructure. It still required a full-blown OS, so this is where it's kind of a bit heavyweight, right? It wasn't as nimble as we needed it to be, and that reflected in the times for how long it took to spin up, how long it took to move these images around. But we did start to see some smarter resource usage. In terms of getting more out of the servers, squeezing more juice out of the CPU, squeezing more juice out of the RAM, or more memory out of the RAM. Getting your bang for your buck on your server. And kind of in 2014, someone like Chris would have said, we want to control our own destiny. And what do they mean by this? They really meant like we want to take this thing Docker as a base of what we're going to start using to ship our application. And some of the reasons why the developers were interested in container technology in the first place is really this developer-centric tool chain. So you could easily work from your workstation and guarantee that what you were doing locally was going to be working in production. Also, API first development, CLI tool chains. It was a great ecosystem. You could kind of extend this analogy for Kubernetes as well, but effectively, it was lightweight and it was very fast to spin up and spin down environments. You could easily create a container in seconds. Comparing that to VM times of minutes or hours, a big improvement there for developers. Also, a big improvement for the operations team. But day two, patching containers is still a problem. Even with container technology on Kubernetes, patching and patch management is a big problem. Orchestration, when you're just using a container technology like Docker, still challenging to orchestrate all of those different parts of the application. And doing deployments is still challenging. You've still got things to think about downtime in deployments, and all of these are still quite big challenges. However, this started to make DevOps look more viable, which for thing of the developers taking more ownership, more control of what's going out into production, and that whole release lifecycle. But the key thing to remember here, and in many cases, you've taken your monolithic application, and the application architecture still hasn't changed. It's exactly as it was. Well, maybe there's some small changes along the way, but really wholesale, you've taken what you had on hardware, put it into a virtual machine. What was on your virtual machine is now in a container. And really, this is infrastructure modernization. And that's not a bad thing. There's many things that we've gained from the infrastructure modernization. But effectively, we haven't really moved the needle on what that application does, how it works, how it's architected, and how we can deliver new capabilities out to our users. Infrastructure definitely helps here, right? Like if you can spin up an environment quick, that's obviously going to be a benefit. But really, we haven't always looked at the application architecture. And so this kind of takes us on to the topic of software practices. And just as the infrastructure has evolved, and lots of capabilities have changed there, we've also started to think around how we change our software development practices. So if we look at then, again, going back, it's kind of this lack of collaboration. It's not my problem. Each team and each part of the organization had separate tool chains, different incentives, opaque processes. And we're seeing a move towards DevOps with a shared responsibility, common incentives, tools, process, and culture embedded with this group of people that have the shared responsibility for the success of the service, not just the success of the infrastructure, not just success of the application code, this common team. We also see that manual testing and releases are still prevalent. Lots of organizations, especially enterprises, have large armies of people doing this whole process. And really, this is leads to bugs in production, releases once every 6 months. Modern software teams now are wanting to do continuous delivery. This is not a new concept. It's been around for a while, but really, if you look at enterprises, large organizations, they're really starting to think, like, how can we deliver this software in a way that's automated? How can we release early and often? And how do we focus on getting higher quality code so we have less bugs? And finally, the monolithic architectures, where they're tightly coupled, they're slow to deploy. You have huge amounts of time waiting for integration tests and the teams of people that manage that process. And really, modern software architectures are moving towards loosely coupled components. You might call this microservices, but really this is being able to automate and deploy things without waiting on other dependencies. Being able to move at your own cadence and release features that are valuable for your users when they need them, not having to wait for the rest of the monolith to kind of release with you. And so when we think about the ecosystem around the software as well, this is a snapshot of the cloud native landscape from the CNCF. And you can just see the amount of new technologies and new enablers that are out there in the ecosystem is just boomed. Some of these focused more on the infrastructure. You've got the provisioning layer, but there's also a lot around the application development. Changing the way that we build, package, manage, architect these applications. Things like service meshes, API gateways. These are all things that can drastically change how we might architect an application. And may enable us to give new benefits to the consumers of those applications. And so in this talk, we're going to be talking about two main topics here. We're going to first focus on how to find high-value modernization projects within your application portfolio. Then we're going to focus on choosing the right strategy and accelerating modernization. So let's dig into the first topic of how to find those high-value modernization projects. So this is going beyond containerizing. How do we find those applications that are going to benefit the most from modernization? So want to think about three key questions that you want to ask yourselves when modernizing a wider portfolio. Some of you out there might have 10, 20 applications in a small business. Others might be part of an enterprise with hundreds of applications or thousands. Those might be split into different business groups. So really, which applications should be modernized first? How do we pick that first application? Some of the things we're thinking about here is how do we find the highest measurable business impact with the least effort, right? Like, what can we do to get the biggest bang for our buck in terms of modernization? Which applications are really causing pain for your users? Which have a constant outage? Which ones are really behind the feature sets compared to your competitors? We need to be asking these questions. Thinking about, should we cover different types of applications so we can learn what works? We think that's a great idea. And then you're going to ask yourself, well, how far should we transform these applications? We've been rehosting them. We've been moving from VMs to containers. What's next? Do we re-platform this to something like Kubernetes? Do we refactor the application? Do we rebuild it? Then how much do we have to spend to achieve that? What's the investment versus the outcome? And really, we want to be iterating and releasing value often. And which of these methods will allow us to get something out that's going to release value to the organization quickly? Finally, thinking about what is a technology stack, environment, team. This does make a big difference. We know that some products that you might buy from your vendors are not really going to be friendly in these higher abstractions. Are you using, is it on-prem today? Is it on a cloud provider? What's the software stack? Like, what languages are you leveraging? Is this an application written in C? Obviously, that's going to be a lot harder to modernize than an application that's maybe a Java app. And are these already built into different components, or is it a monolithic system? Does it have a full-time product team? That's a key thing here, as we see. If you're trying to modernize an application that's been on the shelf for the last 10 years, so a lot harder than it is to modernize an application with an active team of developers, product managers that know the application inside out. So really, yeah, think those three questions, like, which application should we modernize first? We're going to take a look at that. We're going to think about how far we should transform, and then we're going to start looking at how we can evaluate some of the technology. So firstly, off, to recognize most people's application portfolios are a real mix of things. You might be lucky and you're already in a very modern world where you're from a startup and, hey, you just got microservices. This talk might not be too relevant for you, but maybe stay around and you might learn something. Let's see. But for example, many financial services organizations have huge batch architectures that rely on monoliths. They rely on COTS products. They're fronted by enterprise service buses. You might have large data architecture where you're using technologies, Greenplum or massively parallel databases. How do we run and manage those technologies in a modern environment? You might leverage things like Java, .NET. And so you're going to see that your application estate, there's no one-size-fits-all modernization pattern. Each of these applications you need to look at individually and assess them and figure out what are those patterns that you can unlock that business value we talked about earlier. Many of these applications will struggle with these things. I'm sure, feel free to put some comments in Slido if some of these things resonate with you, but many applications are struggling with release cadence to meet the needs of users. Many of them have problems being portable across environments. Many of them have challenges with patch management, staying secure, horizontal scaling, meeting customer demand. Thinking about, how do we get our app teams to adopt best practice? This is another problem with modernization, is that if you change the technology, you don't necessarily change the people. Monolithic architecture is hard to change. Like, we haven't established any patterns or cookbooks. We don't know how to modernize. And then really, we have lots of constraints from our proprietary products we've acquired over the last 10 years. And these are all real challenges that you need to look at and really do some deep thought about. But we want to make sure that we're doing this in a way where we're not going to spend the next 12 months doing analysis. And so what we're going to talk about next is some techniques that will allow us to start assessing our application portfolio in a much quicker way, so we can learn and answer some of these questions of, is this a problem for this application? So one quick way to start thinking about this is grouping your application into buckets. This could be by line of business. This could be by application characteristics. Here we've done a simplification of 2 buckets, for an example. We've said, let's put all of our Java applications that are related to trading into a bucket, and let's put a set of finance applications that are all .NET into a bucket. And then why don't we start to look at what's the makeup of these applications within this portfolio? So you can see that maybe 3 applications are modern, maybe 3 are native or data dependent. You've got the finance applications, maybe there's some modern .NET, maybe there's some desktop applications. And then what this allows you to do is look into these buckets and start to think about, for these kind of applications, what are the right patterns, what are the right approaches to take, and how much complexity is it going to be involved. And it really breaks down what was a rather large problem into some quite well-defined areas that you can further invest in. So once you've got the buckets, we like to leverage automated application analysis tools at VMware. A few of them I'm going to call out here. They might be relevant for you. There's lots more out here. But previously Pivotal, now VMware, has developed a set of tools around this that we've got in closed beta right now. We're testing with lots of customers, but effectively, can we do a cloud readiness assessment for Java and .NET applications? Can we automate that process so we could take an application, run an automated analysis process against it, and give recommendations for where are going to be problems in modernizing those applications? IBM have a great toolkit from WebSphere, so many of you might be WebSphere users out here. Oracle has not Oracle, sorry. Red Hat has a similar one for their application server as well. These really identify the changes to decouple you from those Java Enterprise middlewares, which we see as a hugely prevalent problem. These middleware systems that application teams have leveraged over the last 10 years and heavy lock into those systems. These tools can start to tell you how to untangle yourself from those application servers. Then things like to think about security, so looking at where there might be vulnerabilities, and the OWASP project, great tool here to identify vulnerabilities in your application. That might be a great area to say, hey, we've got such a large security problem with these outdated libraries in our project. Let's start with a modernization project here because it could be a huge risk for our business. Other things to look at is automated detection of languages. I'm sure that many of your organizations might have this, where you've had groups of developers come in and flavor of the month was Scala, or flavor of the month was Groovy, or X language, and those people have probably left your organization. So how can we start to detect what languages are in there, what patterns, characteristics are leveraged from those different software languages? And then also thinking about licensing. Are we leveraging lots of proprietary licenses? This can be another reason to modernize. Move away from some of those proprietary libraries that you might be paying for. How can you decouple yourself from those so that you're moving more towards open source based models? So definitely start to look at leveraging these tools. This will speed you up. It'll make you go faster. You can, and we've seen lots of organizations go and do very heavy manual analysis process, which leads to this taking lots longer. The tools can kind of point you in the right direction and allow your team to move faster through application analysis. Another thing to think about, and is often missed, is really what are the business opportunities for the application? So yeah, you've put them into buckets of technology or business domain, but really, what are you hoping to achieve if you modernize this? Is there opportunities for savings? Can you repurpose budget that you might be spending on licenses for your, if you modernize and move away from those? Can you improve the stability of the application? So thinking about, is portability important for your organization? Do you have a migrate to cloud strategy where you're moving things to AWS or to Azure, and maybe you're moving, maybe you need to deploy to both on-prem as well? Thinking about scalability, that's a huge topic for many organizations right now, especially relevant in the coronavirus that we're going through now. If you look at most online providers, how are they coping with scale? If you're on hardware, hey, how would have I scaled up my service? So looking at, can we leverage things like auto scaling to deliver improved capacity planning and better user experiences? Can we improve the security posture? What opportunities are there? If we improve the security, does this mean that we can release more confidently more often? Can we mitigate security vulnerabilities faster? It's arguably quicker to could be quicker to patch a container than it would be to go through and do this for a hardware OS. And then finally, like, what speed can we bring? Is there opportunities to accelerate the product lifecycle? What could you achieve for your product if you could release it once a week rather than once a year? And also thinking about that developer productivity. How can we give that development team an experience where they can go have an idea and get it in production within a day? So what we recommend doing here is going through this for an application, and this is called the 5S model that we typically use to categorize those characteristics. And these can be your measures and benchmarks as well. So later, once you start doing some work, you can say, are we seeing, we picked resiliency and repurposing budgets, are we able to repurpose some of that budget? Have we got improved resiliency? And so we want to be doing the build, measure, learn cycle. And eventually we want to see, like, did our customers receive some benefit, right? Yeah, we might have improved our cost profile for the application, but at the end of the day, we want to make sure the users of this application are having a great experience, improving their satisfaction. And so really all of this comes back to making a better experience for your customers and your users. So once we've gone through this exercise, we've looked at the technical quality of the application, or what's a technical condition. We've looked at the business value in terms of what's the opportunities we've got there. And we can characterize this in terms of two scales, right? Going from worse to better on both technical wellness and business value. This is what I'm showing you here is the time model from Gartner. And really this aims to put applications into 4 buckets. This is tolerate, invest, eliminate, migrate. Or if you want to spell time correctly, it's tolerate, invest, migrate, eliminate. But effectively what we're looking here to do is plot applications from those various buckets onto this chart. Ideally looking to identify a top 10 applications that we can start with that will have a business impact. And you can start to see that these applications probably fall into the invest category. So this is often thinking about refactoring the application. Also, potentially some applications you might look at that more fall into the rebuild, especially where there's going to be a huge business impact. Those might be ones that you want to spend some money on here. Okay, so once you've mapped out using the time model, really you start to think about, the applications that are important and that you might be able to drive some pretty interesting outcomes for. But how do I choose the right strategy and accelerate the modernization of this? I want to see results in weeks, months, not years. So let's take a look at that next. So when thinking about selecting a modernization strategy, we like to think of this funneling process. And so what we really just described here is stage 1 of the funneling process. This is really what are the business and technical filters and prioritization and scheduling factors we're going to consider to pick those first applications to go through a modernization. Once we've decided that, we can then have a prioritized list of applications that we're going to look at making recommendations for. And this is really thinking about what outcomes can we drive by applying the following strategies. Thinking about the rehost, replatform, refactor, rebuild. All of these require different levels of investment and can drive different outcomes. But it's important to understand that we're trying to, we want to make sure that we don't rebuild everything because that, your business will go bankrupt. But maybe we don't just rehost everything because that's what we've been doing for the last 10, 20 years in terms of going from hardware to VM to container. Once we've picked the strategy, we want to go through that build, measure, learn, iterate. Was this an application that was a good choice? Was our strategy correct? Was refactoring this to microservices the best idea? Or should we have actually gone more extreme and rebuilt some parts of this application to unlock more benefit? You can then come back and adjust this model so that the next application you choose to modernize has a better chance of being successful. And so then the next question often comes to, well, okay, we're going to refactor, but what's the right abstraction here? So we've put together this model showing some suggestions of kind of what applications go well to which parts of the abstraction. So going from left to right, thinking about IaaS, really applications here, potentially this is where they're on legacy hardware. They've got some real tight coupling to your environments, or maybe they need particular drivers installed or particular configurations. Maybe it's packaged software that's not yet container ready. That can still land on those places, but often doing modernization on IaaS introduces additional complexity. If you look at the things that a CAS platform or PaaS platform would take care of for you compared to an IaaS platform, there's still a lot more that the operations team needs to do, a lot more that the development team needs to worry about. Moving on to up the layer into the CAS platform, something like Kubernetes, it's good for stateful workloads. We've seen that it has much improved management of stateful workloads now. It's good for packaged software where vendors will give you a Helm chart or they give you some package to deploy. You get all those benefits of extremely fast spin up time. You get the benefits of being able to have applications dynamically scaling. But we find it's a good balance where you might need a bit more fine-grained control of the application and its environment than you would get from a PaaS platform. So something like a Cloud Foundry, a Heroku, or Amazon Elastic Beanstalk. So thinking about what applications would fit well into a PaaS environment, well, this is a really custom-built software, typically targeting Windows or Linux. Potentially, you might have a Docker image for this application. Highly likely, this is stateless, so you're not depending on state in any way. So you don't need to leverage any kind of file system operations on for stateful interactions. Web applications are great here. APIs, batch jobs, streaming applications, they all fit very well into a PaaS abstraction. Again, in the PaaS layer, you're going to see that much more is taken care of for you. Thinking about routing, networking, application lifecycle management. Lots of that is handled in PaaS platforms. Finally, you get to the latest and greatest, function as a service platform, commonly referred to serverless. Really, this is real-time stream analytics, notification engines, anything that could be spun up on the fly really fits well here. Often, you're going to see that it might not just be one of these you're choosing. For very complex applications, you might have part of the application still deployed into IaaS. Part of it fits well into the CaaS model. Some of those applications with custom-built complex APIs fit well in the PaaS layer, and maybe there's some use cases where you might fit well into functions as a service. So when thinking about the abstraction you choose, try not to be too hung up on picking one. There can be situations where you can get real business outcomes by having a hybrid approach of these abstractions. Next, you want to think about choosing your tool chain. So a common tool chain we're seeing a lot of our customers adopt is based around Spring Boot. So Spring comes out of the Java ecosystem, late 2000s, really took off trying to simplify the complex world of Java Enterprise. We saw Spring Boot effectively coming out in probably around 2013 time, I think, for the first version, and that aimed to massively simplify Spring development. We then had a lot of great input from Netflix, bringing a lot of these Spring Cloud concepts. So how can we build resiliency into our services? And then when you combine that with a modern platform like Kubernetes, Cloud Foundry, we really see that you can start to define what could be a cloud native approach to building net new software, or bringing that software capability in-house. So really what you want to do is think of what's your organizational tool chain. What do you want to give developers the freedom to use, and trying to have the right tool for the right job. Taking a look at Netflix, this is an interesting case study here, right? So Netflix originally built most of their Java libraries in-house. This was commonly referred to and open source as Netflix OSS. It was a set of tools to do this cloud native development. Effectively, over time, the Java team at Netflix was struggling to meet production requirements, launch new applications, and they made the decision actually to fully move over onto Spring Boot. And at the time of writing, this was from last year, they'd moved 22% of their Java applications in production onto their new Spring Boot platform. They were leveraging Spring Cloud, which packaged up a lot of those innovations from Netflix OSS and actually made those part of the Spring ecosystem. And so what you're seeing here is even organizations that are cutting edge as Netflix are still thinking about how they're modernizing, how they're evolving their tool chain, and how are they picking the right tool to solve their business outcomes, meet the needs of having millions of users watching this content. So the other thing that successful organizations are doing here as well is once they start to modernize, they create modernization cookbooks. And the modernization cookbook, effectively think of the pattern is when you're going through the first few modernization, you'll have the chefs, they're making some tasty recipes. At some point, if you want to start modernizing more application, well, you need some cooks. And the cooks are great at following recipes. And so the recipes that you've built and solve some of the hard problems enable you to go faster with modernizing more applications. Often we're recommending that these recipes are written down in Git. The cookbook can be stored in and assembled using a CI pipeline. This will give you a lot of your knowledge in your organization in a central location. If developers are wondering, hey, I've got this application and I want to start putting this into a Docker container and deploying it onto Kubernetes, how do I do this for a .NET application? Great question. Go to the codebook. Over time, this becomes a real asset. And organizations have leveraged this. Start to see the time it takes from we want to modernize this application to the time that you've delivered something into production, drastically decreases. So finally, I want to start talking to you about one technique we're having a lot of success with around deconstructing monoliths. We've been leveraging a method called Swift, which is based on domain-driven design, takes a lot of inspiration from event storming. And this is the next level of detail to go into when you're really looking at that refactor, rebuild part of the application. This typically works well when there's not too much context in your organization anymore around what does this application do? How does it work? Who's responsible for it? Like, what's the flow of events? And we often start off with defining what are those objectives and key results of this application. So going back and looking at what was my strategy we decided earlier. What business outcomes are we trying to drive for? What technology outcomes are we looking at? And so for those of you not familiar with this, objectives and key results allows you to decide on a direction for the outcomes and the approach and agree on what the key measures of success will be. And we often say that that's measured by the key result that you're looking for once this application has gone through this process. And by measuring this, you can say, how successful have we been against our objectives? If you don't measure it, then it's just doing technology because it's really fun. And we want to avoid that. So what we start to then look at is, for this application, how can we run an event storming session, which is a highly collaborative modeling exercise where it makes sense of a very complex business domain, gives the team a common language, and identifies trouble spots, starting points, different flows within your system. And what we're trying to do here is really get that map, that shared understanding within the team. We'll then look at selecting thin slices of functionality. So this is often, you'll hear slicing the monolith is quite a complex term, or strangle the monolith, where you'll be looking at taking these flows in the system and be able to extract it and find that sweet spot to start modernization. By taking these thin slices of functionality as well, we are able to unlock business value. So while the application, maybe it's still running as a monolith for 90% of it, but you could take 10% of that functionality and start to offer new experiences for the customer, or better resiliency, higher scalability. And so if you pick a point that's really struggling with scale in your application, extract it from the monolith, deploy it onto a modern platform, leverage microservice-based architectures, leverage those different CNCF capabilities, you can really start to see quick outcomes for the business. So once we've identified that thin slice, we want to kind of draft a desired notional architecture. So as part of Swift, there's a methodology called Boris, which allows us to start to model out the different flows, connecting the business capabilities in a certain sequence. This allows us to then identify those domains, those potential services. And you can think of this as, how does my software want to be modeled? How does it want to be architected? Which gives you the vision. And it also enables you to start saying, okay, well, this part of the workflow is higher priority. So I've identified which services we should start with building, which gets you to the point where you have a backlog. So you can start to say, these are the first APIs we're going to build. These are the different events that we're going to have queues based on. Here's the different user stories, so we can actually start developing this. And effectively, we then want to get to a place where we have tested and working code. Taking some of these low-level designs that we've gone through and implementing them, and checking that these are actually going to get us the outcomes we're looking for. And finally, once we've proven that we can drive these outcomes in production, these are the patterns that we're going to say, okay, other teams, if you're going through this modernization process, follow these patterns. And so this is a very effective technique. So taking from that monolith that's in a container now to how can we start to get a modern microservices event-based architecture in place. So all of this and more is in the white paper. So a lot of the techniques I've talked about here, where we're going through the funneling process, how to do the Swift process. This is in a new white paper we've just launched called Tackle Application Modernization in Days and Weeks, not months and years. So great white paper, really goes into all the topics we've talked about in the presentation in much more detail. And so yeah, effectively, what we've seen is a bit of a common story for modernization approaches in enterprise, particularly enterprise. We talked about how to find value in modernization projects within your application portfolio, and then touched on some of the ways you can start to choose the right strategy for accelerating modernization. And covered a bit of a specific pattern for monolith decomposition. So I think we've got around 5 minutes now for questions. So if there's any questions, please put them into Slido and we can make sure to cover them off. Okay, I'm not seeing any questions just yet, but we'll give folks a few more minutes just to see if there's anything that pops up. Okay, well, if there's no questions, I'll give everyone 5 minutes back so you can grab a coffee and a quick break before your next session. But no, thanks for your time today. Feel free to follow up with me on Twitter. You can follow me at Alex Evade. I'm happy to take questions there as well. But no, thanks for your time, and yeah, enjoy the rest of the conference.